Good morning, students. Today we are going to discuss about power flow problem and various type of buses that are used in power flow problem. Okay. So these are all the content we are going to see in today's class. First, what is power flow analysis. Second, we will discuss the need of power flow analysis, and third, we will discuss the classification of buses, and finally, we will discuss the need of slack bus in a power system. Okay. Now, before going to the original topic, first I will remind what is a power system. Right, so power system is a combination of generation, transmission, and distribution. Right, so the typical structure and concept we already discussed in previous class. Okay, so next that analysis, that is a power system analysis, it is mainly for developing the mathematical model of how the power is generated and how it's transmitted and how it is distributed to the consumer. Right, so that is the power system analysis. Okay, so during the power system analysis study, we will model the system, and we will create some distribution in that system and analyze various parameters in the system, and finally conclude whether the system is stable or unstable for that particular type of disturbance. So that is the termed as a power system analysis. Okay, so this is a typical structure of our system. So it will start with generation, transmission, and ends with the distribution. So here this is primary transmission, secondary transmission, primary distribution, secondary distribution. Okay. Primary distribution go to big consumer like factory. Here we always take 3-phase supply, and secondary consumer are our home consumer. So here from this we are taking single phase supply. Okay. So that all part discussing we already discussing in previous class. So next power flow problem definition. Okay, so power flow study, it is a steady state study. So steady state study means whether that is it does not depends upon the time. So that system operating condition is always time. It is irrespective of time. Okay, that is always same. That operating condition is always same. Now the main objective of this power flow problem is to find out the bus voltages, bus angles, and real power reactive power flow in a system, that is in a transmission line. Okay, so this is our main goal in power flow problem. So that can be calculated with the help of different type of algorithm, Gaussian, like Gaussian, fast coupled, and Newton-Raphson method. That problem algorithm and modeling and the problem solving method is we will see in next class. Okay, so power problem definition is the determine the voltage, current, real and reactive power flow in a system under given load condition. Okay, so that is the definition of power flow problem. Okay. So next we will see the need of power flow problem, need of power flow analysis. Okay, so why we are doing this power flow analysis is to test the system for different hypothetical situation. Okay, that means for example, if I want to out some line for maintenance, so that outage whether affect other part of the system, so that I have to know prior to the outage of that particular line. Okay, otherwise it causes to severe effects. So that for that I need this power flow analysis. By doing this power flow analysis, I can know the that particular power flow various line for a particular line outage condition. Okay, so that is the main need of power flow analysis, to test the system for some situated condition, some unregulated condition, or you can say some hypothetical situation. Okay, so next we will discuss about different classification of buses. So there will be 3 major classification of buses. First one is load bus, or PQ bus, voltage controlled bus, or generator bus, slack bus, or swing bus, or you can term as a reference bus. Okay, so generally bus contains 6 parameters: voltage magnitude, voltage angle, real power generation, reactive power generation, real power demand, and the reactive power demand. So these 6 parameters may be known or unknown, depends upon the type of bus. Okay, so first we will start with the load bus. So load bus, here they will mention the real power demand and reactive power demand. Here we have to calculate the voltage magnitude and phase angle. So for load buses, the known value is real power demand and reactive power demand. Unknown value is voltage and that del means the power angle. So that voltage and power angle should be calculated with the help of first law algorithm. In generator bus, they will mention the real power generation and voltage magnitude. That voltage magnitude always assume as 1 per unit, because it can be regulated with the help of a voltage regulator. So we can assume this voltage magnitude as 1 per unit, and real power generation is also specified in generator bus. Okay, so here we have to calculate reactive power generation as well as bus phase angle. Okay. Next, the third one is slack bus or single or reference bus. This is a special type of bus. Okay, so here we have fixed both voltage as well as phase angle. So voltage is fixed as 1 per unit and angle is fixed as 0 degree. So here we have to calculate real power generation and reactive power generation. So real power generation and reactive power generation are non-value. Right. So next we will see what is the need of slack bus. Right. So the need of slack bus, simply we can see the need of slack bus is to account the line losses. Okay. So for balanced power system operation, the generation should meet out the load demand as well as line loss. Right. So but the line loss depends upon the line current. So that mainly depends upon the voltage magnitude and angle of the bus. Right. So without knowing this value, that is voltage magnitude and angle of the bus, we cannot calculate the line losses. Okay. So for this reason, a generator bus is usually chosen as a slack bus without specifying its real power. Okay. So for slack bus, we have to calculate the real power value. So always we take that generator with high capacity bus as a slack bus, and it is assumed that the generator connected will supply the balance of the real power required, that is additional power that without the line losses that can be supplied with the help of this slack bus. Okay. So this is basic need of slack bus in power flow study or in general power system. Right. So with this I conclude this my session. So in this session we discuss about what is power flow problem, what is the need of power flow problem, and various type of buses that are used in our power flow problem. Okay, thank you.